Very good evening. Today, I'm going to discuss a topic named array of pointers. Last few classes, I discussed about the topic pointers. First, we discussed about the very basic of pointers. Next, the pointer arithmetic I discussed, and how pointer is related to the one-day array. Using pointer, how we can access the elements of one-day array. That also we discussed and explained with a programming example. Today, I start discussion with the topic array of pointers, what it is actually. So far, we learnt about various types of array, like an integer array, float array, character array. What it means? Integer array means it is an array of type integer, means it consists only the integer type of elements. Similarly, if we talk about the float array, that means an array which consists the elements of floating point numbers. Because according to the definition of array, we say that it can store only homogeneous type of elements. So now I'm talking about a topic which is array of pointers. That means today we are going to introduce an array where each and every element of that array is a pointer variable. We already know what is the definition of pointer variable. What it is? Pointer variable is such a type of variable which can store the address of another variable. So what is an array of pointer? An array of pointer we can define such a way, that means it is an array where each and every index, rather each and every element of that array is basically a pointer. That means a variable which can store the address of another variable. So that's why the first point says an array of pointer is nothing more than array of elements that contain the address of values in memory. That means each and every element is a pointer variable. The format for creating an array of pointer is similar to the format for creating any other array. Just like this, the syntax of declaration of array of pointers is data type star, it's an indirection operator, array name, the name of the array, and within bracket you have to mention the array size. So replace this generalized format to a very specific one. Say I'm going to declare an array int star ARR size 5. What it means? ARR is an array of size 5. That means index lies between 0 to 4. And each index will behave like a pointer variable. And definitely, as because I declared that is a int star ARR, that means each and every index of this array is capable to store an address of another integer variable, as because I mentioned the data type as int. Try to understand this line. Specifically, I am going to declare an array of pointer in this way, int star ARR size 5. It means ARR is an array of size 5, As because it is array of pointers, that means each and every index will behave like a pointer variable. Which type of pointer variable? Integer type of. That means each and every index can store the address of another integer variable, as because I declared it as int star ARR. Instead of int star, if we declare the array of pointers like this, float star ptr size 5, float in place of data type, I mentioned the data type float, then star, then ptr, then size 5. What it means? It means it is an array of size 5. That means each and every array of pointers of size 5. That means size of the array is 5. Each and every index is capable to store the address of another variable. Which type of variable? Answer is float type, as because I declared the data type as float. Second point actually says this: the array type should match the data type it points to. The indirection operator precedes the name of the array, and the number of elements, that means pointers, because I mentioned earlier that each and every index is nothing but a pointer, is enclosed in the braces, that is size that I declared with the array name. To assign an address to an element in an array of pointers, use the address of operator. That we already know. To assign the value of a pointer variable, we have to use address of operator, ampersand. Fine. So this is the basic fundamentals of array of pointers. So it is nothing but an, as a conclusion, what we can say, it is nothing but an array, but each and every index of this array will behave like a pointer variable, and the data type says which type of pointer it is actually. If it is float, that means all the pointers can store the address of another float variable. Now try to implement this concept by using an example. So just a minute. Is it visible to you? Yes or no? No. Just a minute. Yes, I hope now it is visible to you. So look, here what I have done, I have considering three integer variable x, y, z, and I've declared a array of pointer, name of the array is a. So what is this int says? This int says int star, basically. It says it is an array of pointer size 3. That means this array consists 3 elements. Definitely index lies between 0 to 2, where each and every index is basically used to store the address of another integer variable. So look what I have done. A0 equal to ampersand x. That means A0 is basically storing the address of x variable. A1 is storing the address of y variable. And A2 is storing the address of z variable. And all three are capable to store the address of an integer variable, as because I declared this as int star. So using this pointer, when I use the indirection operator over pointer variable, definitely it returns a value that we discussed earlier. So when I'm writing star A0, that means it is actually saying that value of, in place of A0, what we actually it is, it means ampersand X. So value at address of X. So definitely it will return 10. For the second case, it will return 20, and for the third case, it will return 30. So this is the concept of array of pointer which we have used in our program. Look, try to execute the program and check the output. Output will come 10, 20, and 30. Yes. Fine. So I hope this concept is clear to you. Next topic that I'm going to discuss with you, which is function returning a pointer. We know what pointer is. We have used pointer in different cases. Today we learned array of pointers. Now we are trying to introduce a new concept where function is returning a pointer variable. Earlier we have seen function returns integer, function returns float, function return character. Today I'm going to discuss function return a pointer variable. So definitely the declaration syntax of the function will be like this. In place of return type, in the place of return type, you must have to write a pointer type. That means if you write float star, that means function return a pointer which is pointing, which can point to a float variable. When I am writing int star, that means function fun is returning a pointer variable of type integer. Pointer variable of type integer means a pointer which can store the address of another integer variable that we know already. And the function that we considered in my program, it takes two parameters. One parameter is another integer pointer, and second parameter is a normal integer variable n. Hopefully this much is clear to you. So when the new thing is in this case is when the function returns a pointer, the return type should be int star or float star or cat star, depending upon which type of pointer function returns. Here my function fun returns a value of an integer pointer, returns an integer pointer means returns a pointer variable which basically stores the address of an integer variable. So that's why the return type of this function is considered as int star. And the function is taking two parameters. Now coming to the main program, an array initialized ARR 11, 22, 33, 44, 55. Considering a local pointer variable start ptr which is local to main, fine. I I equal to, not I equal to, n equal to 5. N means actually number of elements, nothing else. So what I have done, I am calling the function fun here with the two parameters. First parameter is the array name and second parameter is n. According to our last discussion, the array name is a pointer, variable. Array name is a pointer variable, fine, which can store, which actually storing, not which can store, which actually storing the base address of an array, starting address of an array that we already discussed. For 1D array, the name of the array, ARR means it is basically ampersand of ARR 0. So that means when I am passing ARR, that means it is basically ampersand of ARR 0. And the second parameter is normal integer. Now I am moved to the function fun because function call is there. But because this is a function call, the cursor, the control of the program is automatically go to the body definition of fun. What is the body definition, or rather function definition of fun? Star of x. This x is very local to this function fun. Try to understand. So ARR is basically replacing this x. So x means ampersand ARR 0, right? And your y means basically number of elements, that is n. So I am iterating a loop from 0 to less than n. Y is basically n because n is copied to y. So when I'm writing less than y, basically it interprets less than n. So what I'm doing, star x, try to understand, star of x plus y. We know the meaning of this is actually x of I, that we learned in my last class. Star of x plus I is equivalent to x of I. And this x, in this case, x and ARR are pointing to the same address. Because x is replaced by ampersand of ARR 0. Right? So x plus I, x plus 0, x plus I when I becomes 1, so x plus 1, x plus 2, x plus 3, x plus 4, that gets modified. That means value of xi gets modified, and with each and every terminal terms, you have added 100 over there. So 11 becomes 111, 22 becomes 122, 33 becomes 133, 44 becomes 144, 55 becomes 155. We haven't changed the value of x. Try to understand. We haven't changed the value of x. We are adding I with x. We are adding I with x. That means automatically when I is 0, that means we are talking about the first element of the array. When I is 1, we are talking about the second element of the array. When I is 2, we are talking about the third element of the array. Similarly, when I is 4, we are talking about the fifth element, because array index starts from 0 and lies 0 to 4. So when I value is 4, that means that I'm talking about the last element of the array. So each and every cases, what we are doing, we are just modifying the existing value and we are adding 100 to each and every term. And finally, what I return? Look, the return statement. Return X. What it means? Returns X means I'm returning the X address. What is X address actually? X equal to what I can interpret, X equal to ampersand ARR 0, because I have replaced X with the value ARR, which is nothing but ARR. Array name is basically what? A constant pointer which is storing the base address of an array. So that's why X means basically the base, storing the base address. So when you are returning X, that means you are again returning the same array base address. The base address of the same array. You are returning the base address of the same array. And that base address you stored inside where? Inside the variable PTR. Inside the variable PTR. So using the loop, what we are doing, we are printing the value of that array star PTR plus I. The star PTR plus I is actually PTR. If PTR is the base address, that means PTR plus 0 base address, PTR plus 1 the address of the first index, PTR plus 2 address of the second index. In this way we are accessing all the elements of this array and we are getting the modified result, because if you can actually modify the existing value of ARR, so that's why when you print the value of star PTR plus I, you actually got the value 11 plus 100, that is 111. Next value will be 122, so on, and the last one will be 155. So try to execute and show the output. Yes, desired output we have got. Look, so this is the concept, a function which is returning a pointer value. So far we learned function returning an integer, function returning a float, function returning a char. Today we learned function can return a pointer variable also, and this is the way a function can return a pointer. Next, we are going to discuss another important topic regarding pointer, that is how array name behave like a pointer for a two-dimensional array. In the last lecture, I have shown you some programs and I have given some theoretical concept regarding the pointer variable and one-dimensional array. I mentioned over there that in case of one-dimensional array, today also I repeated that line several times, that for case of one-dimensional array, the array name will behave like a pointer because it stores the address of 0th index, or better to say base address. So now think about a 2D array. Visualize it. How 2D array looks like. Looks like a matrix. Fine. And you already aware how we can take input for a 2D array, how we can initialize elements for a 2D array. And we have already done the address calculation part of 2D array in the row measure and column measure order. And in the most cases, that is in our C language, memory will not physically not like a matrix. So that means elements are in linear, elements in memory remains in a linear order. They will not remain like a matrix way. So definitely they follow an order, and most of the cases they follow the row measure address. That means first in the memory, first row resides. After completion of the first row, second row resides. After completion of the second row, third row resides. So that part is already discussed with you. So here in this program, to visualize the concept, better to say to visualize the 2D array, what I have done, I have just taken an array, 2D array of size 3 and 4, that is row size 3 and column size 4. And we are taking input for the elements here, for the array. We are taking input elements for the array ARR. And we are printing those elements along with their addresses. Ampersand of ARRIG, which definitely prints the addresses of the element, and that's why I have given %2. Again, the concept of what unsigned integer, that also discussed with you. So execute the program and show the output first. I'm giving the elements 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, sorry. 11, 12, 13, 14. Look, sharing the output file. Look, this is the input set I have given: 11, 12, 13, 14, 15, 16, 17, 1, 19, 20, 21, 22. And this is your matrix. Look at the address of the array elements. What is the array elements address? First address is 6487568. We know integer is taking 4 bytes over here. So that's why next address is next element, as because the data elements are in row measure order. So first row, that means 11, 12, 13, 14 will be in the memory first. Then the second row. That's why after 80, the address of 15 is 84. The address of 16 element is 88. Similarly, after 96, next element address is 596 is the address of the element, last element of the second row. The first element of the third row address is 600, something 600. It is very much clear to us. Here, the array element resides in row measure order. First row stored first in the memory, then the second row, then the third row. If there are many more rows are there, so then one after another, all the rows get stored in the memory. So think about it, it's a linear memory structure and the elements are stored in the row wise. Each element are taking 4 bytes because this is the integer array. So integer in this case is taking 4 bytes. That's why each and every element address difference is 4 bytes. First one, second one, 68, 72, 72, 76, 76, 80. So hopefully this much is clear to you. Now, another important thing for 2D array is two-D array can be considered as a collection of 1D array. Hopefully you agree with me. 2D array, if I say 2D array is a collection of 1D array, nothing wrong in it. Look, if you consider 11, 12, 13, 14 is a 1D array. Then after 15, 16, 17, 1, that is another 1D array. 19, 20, 21, 22. It's another 1D array. So each and every row of this 2D array, or rather of this matrix, if you consider as a 1D array, nothing wrong in it. So 2D array, we can say a 2D array is a collection of 1D array. And according to our previous knowledge, we know name of an array is a constant pointer that points to the 0th element of the array. Fine. So in case of 2D array, the array name points to 0th 1D array. Hopefully you agree with me. Because just before this line I mentioned, we can consider a 2D array is a collection of 1D array. So here, how many 1D array in this example? 3. First 1D array element is 11, 12, 13, 14. Second 1D array is 15, 16, 17, 18. Instead of 18, I have putting 1. So 16, 15, 16, 17, 1. Third 1D array, we have 19, 20, 21, 22. So if you agree with me that a 2D array is a collection of 1D array, so in case of 2D array, in case of 1D array, array name is a constant pointer which points to the 0th element of the array. If you use the same concept in case of 2D array, so how we can interpret it? We can interpret it, array name in case of 2D array is basically pointing to the 0th 1D array. That means the first row. Are you agree with me? So try to show you this concept. What I actually meant to say. Going back to the program once again. Yes, this is my program. So if I write this line after this, what it will give? It will give you what it meant. Array name means it points to the 0th 1D array. That means the starting address of the 0th 1D array. If I write this line after this ERR plus 1, what is the meaning of this? Try to understand. What is the meaning of this? This means ARR plus 1. If ARR points to the 0th 1D array, that means ARR plus 1 will point to the first 1D array. I will show you the answer so that it will be clear to you. If I write ARR plus 2 in place of ARR plus 1, first I printed ARR plus 1. Second, I printed ARR plus only. First, I printed only ARR. Second, I printed ARR plus 1. And third, I printed ARR plus 2. All are addresses. And we have how many number of row here? 3. So that means we have 3 1D array. First row considered as 0th 1D array. Second row considered as what? It's a first 1D array. And the second row, when I am writing the ARR plus 2, that means it's actually pointing to the third row, because third 1D array. 0th 1D array, first 1D array, second 1D array. Index 2 matlab row number 3. Try to execute the program and showing you the output. The elements are 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Look, I'm sharing the screen. This much we have seen earlier. That is our element set. You consider this 11, 12, 13, 14. These are my first 1D array. And the address of each element I have printed along with 68, 72, 76, 80. Now, what I have printed in the program, I have printed the value ARR. I mentioned which actually points to the 0th 1D array. Look, the starting address of the 0th 1D array is 68, something 68. When I'm printing ARR plus 1, it is actually giving us, it points to the first 1D array. The starting of the first 1D array is, it is 84, 584. Look. And when I'm printing this ARR plus 2, then what it means? It means it points to the second 1D array, that is index number 2, matlab row number 3. This is 0th index, this is index 1, this is index 2. That means I'm talking about when the index value is 2, that means I'm talking about the third row. Am I clear to you? Hopefully, yes. So it points to the address 600, starting address. Then definitely the next question is, what is the meaning of star of ARR 0? What is the meaning of star of ARR 0? Or better to say, first let me say what is the meaning of star ARR. What is the meaning of ARR? I mentioned the meaning of ARR is it points to the 0th 1D array. When I'm saying star of ARR, what it will give? It will also give the address. It will also give you the address. Actually, ARR means what? ARR means nothing but ARR plus 0. ARR means ARR plus 0. So star of ARR mean also star of ARR plus 0. The meaning of this line is, it points, write it down, it points to the 0th element of 0th 1D array. And in case of this, what I have read, it points, try to understand the difference between these two lines. It points to the 0th 1D array. Similarly, accordingly, ARR plus 1, it points to the first 1D array. ARR plus 2, it points to the second 1D array. ARR plus n, it points to the nth 1D array. If you have n number of rows in your program. When I'm writing star of ARR plus 0, that means I'm talking about the pointer variable which points to the 0th element of the 0th 1D array, because it is ARR plus 0. Plus 0, it is a 0th 1D array. When I'm talking about star, that means it points to the 0th element of the 0th 1D array. So both the results are same. ARR plus plus 0 and star of ARR plus plus 0 will give you the same answer, but concept is not same. ARR 0 is basically pointing to the entire row. ARR plus 0 is basically pointing to the entire row. Definitely it returns the starting address. And when you are writing star of ARR plus 0, that means it points to the particular element of the 0th 1D array. Which particular element? That is the 0th element of the 0th 1D array. Try to understand the difference. Similarly, if you change the value of this star of ARR plus 1, star of ARR plus 1 is ARR plus 0, right? star of ARR plus 0, not only ARR plus 0, it is star of ARR plus 0. So if you write star of ARR plus 1, what it will give? What is the meaning of this? And similarly, if you write we have 3 row in my program, that's why I'm writing 3, ARR 0, ARR 1 and ARR 2. What it will give? It points to the 0th element for this line, line number 18. It means it points to the 0th element of the first 1D array. If for the third line, 19 number line, ARR plus star of ARR plus 2, it means it points to the, there's a pointer, this does not give you the value, it points to the 0th element of second 1D array. It points to the 0th element of the 0th 1D array. It points to the 0th element of the first 1D array. It points to the 0th element of what? Second 1D array. Now I'm showing you the output. Elements are 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, up to 22. Sharing the screen. Look, this is my original array that I have taken from user. So what ARR means? Basically points to the 0th 1D array. Address will be 6487568. Look, when I'm talking about ARR plus 1, it points to the first 1D array and the address is 6587584. And when I'm talking about ARR plus 2, it points to the second 1D array, means the third row. The starting address of the third row is 6487600. When I'm talking about star of ARR or slash, same line can be written as star of ARR plus 0. Star of ARR or star of ARR plus 0, same meaning in the case of 2D array. The meaning is, it points to the, what it means? It points to the 0th element of the 0th 1D array. So which one is the 0th element of the 0th 1D array? This one. And what is the address of this element? That is 7568. So it is giving 7568. When I am writing star of ARR plus 1, it points to the 0th element of the first 1D array. So 0th element of the first 1D array is 15. And what is the address of 15? 6487584. That's why you are getting output 6487584. And what is the address of the 0th element of the second 1D array? It is 6487600. That's why you are getting output 6487600. So try to understand the meaning, the difference meaning between the variable ARR and the variable star of ARR in case of 2D array. Both are giving the same output. Though both are giving the same output, but the meaning is not same. So when I'm writing star of ARR plus I, what it is the generalized meaning? Generalized meaning is it basically points to the 0th element of ith 1D array. That means ith row, because we consider each row as a 1D array. We started our discussion that considering that a 2-dimensional array is nothing but a collection of 1D array, and each row can be considered as a 1D array. And data elements are stored in row measure order. That means first row will be stored first in the memory, then after second row, then after third row, then after fourth row, then after ith row. Fine. Very nice. Now, again, going back to our program. So now, if I write, so this much is clear hopefully. If I write star of only ARR plus ARR, actually ARR or ARR plus 0, sorry, ARR plus 0, fine. What is the meaning of this line? Say not J, I'm considering it as class 2 plus 2. Try to understand. Try to understand. What is the meaning of this line? Try to remember the previous meaning. What is the meaning of star ARR plus 0 or only star ARR? This means it points to the 0th element. It points to the 0th element of 0th 1D array. So this is basically returns the address of 0th element of 0th 1D array, right? Do you agree with me? Hopefully, yes. So when I'm talking about star of this plus 2, what it will give? We know pointer arithmetic. Plus 2 means actually it points to the index 2 element. I'm talking about index 2. That's because actually this is the third element. So that's why if I am talking 2, that means index 2 element of 0th 1D array. Again, I am repeating this line. The meaning of this is because this means it points to the 0th element. This is the address of 0th element of 0th 1D array. When I'm talking about this plus 2, that means I'm talking about the second index of, that means the address of the second index element of 0th 1D array. Check the output of this program so that it will be clear to you. "13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Look, star of ARR plus 2, star of ARR plus 0, its value is 64568. That means 0th element of the 0th 1D array. Plus 2, plus 1 is this element, plus 2 is this element. The address of this element is 6487576. Look, the output 6487576. So if I generalize this line, star of ARR, going to one more Going to write one more line so that it will be clear to you. Say if I write star of ARR plus 2 plus 3. This is 2, this is 3. What is the meaning of this star of ARR plus 2? That means it points to the 0th element, 0th element of what second 1D array. Second matlab third row, index 2, third row, second 1D array. 0th 1D array, first 1D array, second 1D array. So star of ARR plus 2 actually points to the 0th element of second 1D array. When I am writing plus 3 with this, that means I am talking about the index 3. It points to the index 3 element of second 1D array. Check the output. Index 3 element of second 1D array. How we can reach? Once again giving the input 11, 12, 13, 14, 15, 16, sorry, 17, 18, 19, 20, 21, 22. Look, star of ARR plus 2, how much it is? 6487600 plus 3 plus 1 plus 2 plus 3. So it basically points to the index 3 element of second row. Second row matlab index 2 row. That is actually the third row. 0th row, 0th 1D array, first 1D array, second 1D array. Second 1D array actually interprets here third row. I'm talking about the third row. So third row, fourth element, better to say. It's storing the address of third row, fourth element. Now, very much clear to us. What will be the next step? Again, I'm sharing the program screen. So if I write a star outside of this, so before writing star, so what is the generalized meaning of this line? Star of ARR plus I plus J. Star of ARR plus I plus J. This means it points to the Jth element, star of, write it down, star of ARR, star of ARR plus I plus J. What it means? It means it points to the Jth element. It is equivalent. It means it points to the Jth element of ith 1D array. So that I proved. In the output screen, we have already shown you the output that it means the actually index 3 element of index 2 row. That means third row, fourth element. Address, not the value. So if I put a star outside of this, so definitely it will give you the value. If I put a star outside of this, which line I have copied? To copy this line, sorry. So just before of this, if I put a star, just outside of this, if I put a star, so that means what? It means the value of that particular address. That's why I've converted it to %d. So look, semicolon missing. Yes, giving the input set. Look, star of ARR plus 2, 0th element of the second 1D array, it points to plus 3, plus 1, plus 2, plus 3. It gives the address 6487612. When I'm putting a star outside of this, that means it gives you the value, that is 22. So what I can say, the equivalent of this statement is nothing but ARR of 2, 3 that we have used before knowing this pointer concept. So using this pointer variable, rather using this array name and the indirection operator, we can access the same element 2, 3 by writing this syntax. So each and every element, so that means each and every element we can use, we can access by using this indirection operator and this array name. Look how we can access, just printing the entire array. It remains M. So instead of %d, it will be star of ARR plus I, fine, plus J whole star. That can be replaced for the value. And if you want to print the address, just print it. If you write the same thing without outer star, it will give you the address. That just I proved in the previous example. So I've just modified this one, yes, and write a /n over there, printf /n, to show you the clear output screen. Let's look. So what this means? This means actually ARR of ij. ARR of ij. Look, same set of output is coming, but we are printing the array values, rather 2D array values, not by using array name and row index, column index, by using the pointer variable, rather the array name, which can be act as a pointer. So this statement is basically this one, not this one. This one is basically equivalent to ARR of ij. So in this way, we can use the pointer variable, better to say array name as pointer variable for a 2D array. I hope this concept is now clear to you. Thank you. Thank you very much for your patience.